Alright, so in this video we're going to apply our definition of torque and calculate the torque due to each of these forces. So we're going to calculate tau 100, we're also going to calculate tau 80, and then what we'll also do is calculate the net torque on this object. Okay, and here if you notice, we want to know the magnitude as well as the direction of the net torque. Just to make sure we understand this whole directional business, okay, think of it very simply on the plane. If a force produces a counterclockwise rotation, okay, a counterclockwise rotation, then the direction of the torque would be positive. On the other hand, if a force produces a clockwise rotation, okay, then we would associate a negative sign with the torque. Now think of this as opening or closing a bottle. In order to open a bottle, you turn the cap in a counterclockwise direction and the cap comes out towards you. On the other hand, to close the bottle, you turn the cap in a clockwise direction and it goes away from you. So the direction towards you is considered positive and the one away from you is considered negative. Okay, and this is how we draw our XYZ axis also. So if this is my X and this is my Y, then my Z will be pointing in this direction, such that if you were to rotate your X into Y, then you have Z pointing in this particular direction. On the other hand, if you had drawn X here and Y here, then Z would have to be pointing in the downward direction. Alright, so let's use all these ideas and let's calculate the torque. Now, what we know is that torque is equal to R times F times sine of theta. Okay, so in this problem, clearly what we need to figure out is, we know F for each of the forces, but we need to know R and we also need to know the angles. Okay, so let's take that approach first and then let's look at an alternative approach. Okay, so calculating R is very easy. We've been given the coordinates of these points, so R is simply square root of 4 square plus 3 square, which is equal to 5. And everything is in meters, so I'm just going to put 5 meters there. Okay, then once we know R, we also need to know the angle that each of these forces makes with the radius. Okay, so I could basically extend this radius out, and what I'd like to know is this angle as well as this angle. Okay, so if I know one of the angles, I can find the others since they're simply complementary angles. Okay, so let us find the angle theta here. Now if we were to extend this line out here and we look at this right angle triangle, then we see that this angle is also theta. Okay, since the 100 Newton force is parallel with the x-axis, we can use basic geometry and figure that out. Alright, so in order to calculate theta, I'll simply use my relationship. The tangent of theta is opposite over the adjacent, which is 3 over 4, and this ends up giving me theta as it's about, I think, about 37 degrees or so. Okay, now once I have my theta, okay, we see that this particular angle is 37 degrees and then the other one happens to be about 53 degrees. So we have all our angles for each of the forces. So now we are in business. We can calculate tau 100. Okay, now tau 100, the magnitude is simply going to be equal to R, which is 5 times 100 times sine of 37, and if we do all this correctly, we'll end up getting 300 Newton meters. Okay, and if we look at the direction, okay, you notice that if the object is pivoted at this point, this 100 Newton force is going to create a clockwise rotation. So you see, this is where the thing is pivoted, and since this is where it's pivoted, and if I exert this force F, okay, it's going to create a clockwise rotation. So we know that this causes a clockwise rotation, and therefore the torque is pointing into the plane of the paper. So this X is the symbol for into the paper. Okay. Alright, now in a similar manner we can calculate tau of 80, and tau 80 is equal to 5 times 80 times cosine of sine of 53, and this, when you calculate, ends up being about 320 Newton meters. Okay, now if you look at this force, Okay, this force will create a counterclockwise rotation. Okay, the best way to do it is, hold a ruler or something in your hand, pivot the ruler at one end, try to pull it up, and you'll see that it will lead to a counterclockwise rotation. So this leads to a counterclockwise rotation, which means that the torque itself is pointing out of the plane of the paper. Okay, and this now tells us that this is a positive torque. So clearly the two torques are opposing each other, and therefore my net torque, tau net, is going to be equal to 320, which is the out, minus the 300, which is in, which happens to be 20 Newton meters, and in the outward direction, so out of the plane. Okay, so this is what my net torque, and as a result, this object itself is going to have a counterclockwise rotation. Okay, in the next video, we will look at the same problem, and we'll use the R perpendicular method and see that you could do the problem very, very easily. Okay, so make sure you understand this method though.